Hi, everybody, and welcome back to Magnificent Math with Mrs. Murray. Bum-ba-da-ba. Tonight we are tackling 5.3 radical equations. So things we need to know is that we always have to identify any restrictions on the variable, and we need to determine whether any roots are extraneous by checking to see whether the values satisfy the original equation. Okay, so we're going to walk through solving these radical equations. So in this first example, we need to state the restrictions on x in this equation. In order to do that, we need to take the radicand, 2x minus 1, and set that to be greater than or equal to 0. Okay, this cannot be negative. Then we are going to move the 1 to this side and solve for x. So we divide both sides by 2. Our restriction is that x must be greater than or equal to 2. That's the restriction. The next part is that we have to solve this equation. So this is the original equation. What we're going to do first is we're going to move the 5 over to this side by subtracting it from both sides to get square root 2x minus 1 equal to 7. Then we're going to square both sides so that we can undo this radical sign. That leaves us with 2x minus 1 equals 49. Solving for x, we end up at x equals 25. Once we get to this point here, it just becomes a basic algebra question. X is greater than or equal to 25, x equals 25, which is greater than or equal to 1/2. So we're all set. Example number 2, we're going to solve for n, and then this has an extraneous root, which means that one of the roots is not going to satisfy this original equation here. Okay, so first thing that we have to do is again determine what the restriction is, and we're told that n must be less than or equal to 5. So moving through and solving this equation, we're going to rearrange this so that the radical is isolated and so that it's a positive value. Okay, it's just easier to work with positive values. Sorry, this is messed up here. So once we're at this point, then what we want to do is square both sides again to get rid of this radical sign. Once we do that, we're left with n squared plus 14n plus 49, and that equals 5 minus n. So we just expanded this. Okay, now that we've expanded it, we're left with a trinomial, and we're going to continue to work with that trinomial by moving these terms over to this side so that we have n squared. When we move the 5 over, we subtract it, so we have 44. When we move the n over, we end up with 15n, and that is now a trinomial. It's a trinomial in which we can factor to determine what the roots are. If we factor this expression, it becomes n plus 11 and n plus 4. You can use the quadratic formula to do that, or you can just use straight up factoring. What we determine here is that n plus 11 equals 0, or n plus 4 equals 0. When we solve both of those equations, we end up with n equals negative 11 and n equals negative 4. Both of those satisfy this restriction, but we need to make sure that they satisfy this equation. So we're going to check. We'll start with negative 4. So we substitute negative 4 in for n. Carrying through with our BEDMAS and order of operations, we end up at negative 7 equal to negative 7. So n equals negative 4 does work. It proves this equation to be true. Checking for negative 11, working through, carrying our negatives through, doing all the work, we end up at negative 15 and negative 7. Those do not equal, so we cannot say that n is equal to negative 11. Our next example, this time we have two radicals, okay? And what we're going to do here is we're going to start by simplifying, okay? We're going to move our 5 over to the other side. So we're going to end up with with 2 plus 3x equals root 5x plus 4. So we're just isolating this larger, more complicated radical. Square both sides, and we end up with 4 plus 4x root 3x plus 3x, okay? We are foiling and expanding this. And on the right side, we end up with 5x plus 4. After we simplify, we're left with 4 root 3x equals 2x. Now what I've done here is I've moved this 3x over to the other side to get 2x, and I've subtracted 4 from both sides, so the 4's cancel each other out. We still have a radical over here, so we're going to square both sides of the equation again to get rid of this radical this time. We're left with 16 multiplied by 3x equals 4x squared. Okay, we are still not done. We're going to expand this to get 48x equals 4x squared. Move the 48x over to the other side to get 4x squared minus 48x. And now, once again, we're going to factor so we can solve for x. Factor out of 4x, and we're left with 4x multiplied by x minus 12 equal to 0. Set both of those factors equal to 0 and solve for x. So we have x equal to 0 and x equal to 12. The last example is a word problem. Okay, so it's just a matter of reading through the problem, substituting the answers in. So this is the equation that we're working with. Okay, so we're told that EK equals the joules of kinetic energy. Okay, and M represents the mass, and then V represents the speed. So the kinetic energy that we have is 28.2. We multiply that by 1/2. Our mass is 0.4, and then it's multiplied by V squared. Multiply both sides of the equation by 2 to get 57.6 equals 0.4 V squared. Divide by 0.4 so that we can isolate V squared. And what we're left with is 144 equal to V squared. Take the square root of 144, take the square root of V. We're left with 12 equals V. So the speed is 12 meters per second for that football. And that's all that I have for you. Again, some of that expanding I didn't show in detail because that's prerequisite knowledge. You should know how to expand a binomial. And hopefully the questions that I asked throughout the video help review and reiterate some of those prerequisite concepts for you. So we'll see you tomorrow in class.